The vertebrate skull began as three separate sections. First, there was what's known as a splanchno-cranium, cartilage around the gill arches, and the first gill arch became the first jaws. There is also a chondrocranium, cartilage which surrounded the brain case, the eye, the nose, and the ear, and finally a dermatocranium of dermal bone. Although these three separate components evolved in fossil jawless fish hundreds of millions of years ago, they are the foundation of all vertebrate skulls which have evolved since then. Some of these components are modified over time, while others, such as the splanchno-cranium and chondrocranium, serve as the embryonic scaffolding around which the later elements derive. When we look at the dermatocranium, the bone, you can see that many of the components have been modified and changed, but nevertheless they have served as the elements of the skulls of fish, amphibians, amniotes, mammals, and then even primates. The jawless fish had large bony plates in their dermatocranium, as did the placoderms. The acanthodians, many small elements. Seeing which are homologous to the dermatocrania of modern vertebrates is difficult, and there's some discussion over this. However, there is a lower Siluran fish known whose skull roof does have homologous elements, and so we begin our analysis of the dermatocranium here. In this fish, you can see that the top of the skull was made of a parietal bone, a post-parietal bone, these compose the majority of it with a large joint between them, and a number of smaller elements, some of which can be recognized and served as the foundation of later skulls. As far as the frontal bone, it is not clear whether some of the elements of the front of the skull, and there were many, were homologs of nasal or frontal bone. So I have indicated them in blue here, but these could be of questionable homology. The frontal and parietal bones compose the majority of the dorsal aspect of the human cranium. As you can see, the parietal bone began as a prominent part of the dorsal cranium. The frontal bone is recognized by the sarcopterygian fish, and from that point expands so that it stretches to the orbit, and the parietal bone is pushed farther and farther back in the skull. The frontal bone will eventually compose much of the orbit, especially as a number of smaller bones around the orbit are lost, and in primates will touch the zygomatic bone to make the post-orbital bar. As the brain expands and changes its shape so that it's no longer straight but rather rounded, the frontal and parietal bones will form a dome of a cranium compared to the flat plate found in fish.